Okay, this is a shear evaluation problem. And we have a 20-foot long beam and it has a factored load of 8 kips per foot over its entire length. What I'm showing you here is just 1/2 the beam. This beam has a width of 14 inches and an effective depth of 24 inches. Concrete is 4,000 and the steel for the stirrups is 60,000 psi. Stirrups are number 3 and they're arranged as shown. The first stirrup starts 4 inches off of the end of the beam, and then you have 14 spaces that's spaced at 6 inches. I'm only showing you half the beam because what is happening on this half is going to be mirrored on the other half. So the first thing we want to do is draw the shear diagram, the VU diagram, and find out what VU critical is. Again, if this is 8 kips per foot over a 20-foot length, the reaction force would be 80 kips. Now the VU critical, we've talked about this before, occurs a distance d out from the face of support. In this example, we're considering the face of support to be at the same place where the reaction is. So in this case, we want to know what is VU 24 inches away from the support. This is going to be solved by the straight line equation, and you can see it down there. If we would draw this out on a piece of graph paper, or in this case a PowerPoint, it might look like this. Again, the ACI code allows you to design for the critical shear occurring at this distance d away from the support. So now that we know VU critical, we'd like to go ahead and determine if our stirrups are going to be adequate. Again, I would mention that that 4-inch spacing, that first 4-inch spacing, is not really a spacing. That's actually a locator. The first stirrup is located at 4 inches off the end. The spacing, the first spacing, and the only spacing in this problem is 6 inches. So we would want to go ahead and calculate V sub C. V sub C is 2 times the square root of 4,000 times the width of the beam, which is 14, times the depth of the beam, which was given as 24. When you calculate that out, you will come up with roughly 42,500 pounds. I've changed it into kips. Next, you'd want to take a number 3 stirrup, which has an area of 0.11 square inches, but again, since this is a U-shaped stirrup, we're using 2 times that for the 2 legs. And you multiply that by Fy, which we've said Fy is 60,000, times D, which we've said D is 24, divided by the spacing, which is 6 inches. So the V sub S at a 6-inch spacing comes out to 52,800 pounds. And again, I've converted that to kips. So the nominal shear capacity, Vn, is going to be equal to a total of 95.3 kips. We always use the design shear capacity, which takes that nominal and multiplies it by a resistance factor. In this case, the resistance factor is 0.75. So our design shear capacity, when we have a 6-inch spacing, is 71.5 kips. Now again, what we many times like to do is take a look at the shear envelope, which superimposes our design capacity on top of the VU diagram. In this case, as long as we keep the 6-inch spacing, we have a design capacity of 71.5 kips, and that's above the VU critical. Okay, so we're fine as long as we keep the 6-inch spacing. The next step, though, since we're asked, is this adequate? The next step to consider is, are we adequate when the stirrups are ended? The stirrups can be ended. Stirrups are no longer needed when your VU diagram gets very small. The ACI code signifies very small as being a VU less than 1/2 of phi VC, or phi VC divided by 2. In our case, with VC equal to 42 kips, 1/2 phi VC is about 15.9 kips. So our stirrups end at 88 inches from the end of the beam. That is the 4-inch first spacing plus the 14 spaces at 6 inches. So now we got to ask ourselves, what is the VU diagram? What's the value on the VU diagram at 88 inches away from the end of the beam? How are we going to find that? We're going to find that by the straight line formula. Okay? And when we calculate this out, we come up with 21.3 kips. The VU value at 88 inches away is 21.3 kips. It's supposed to be less than 15.9, so this is no good. We were okay as long as we kept the 6-inch spacing. We ended the 6-inch spacing at 88 inches out, but that drops us below the VU line at that point, so we're no good. So what's the solution? Well, the solution would be to carry out your 6-inch spacings a few more places. In fact, if we carried it out 2 more spaces, that should say 16 spaces at 6 inches instead of 14 spaces at 6 inches. Now we'd be 100 inches away from the end of the beam. So what would the VU diagram be 100 inches away from the end? Again, straight line formula would tell us it would have a value of 13.3 kips. 13.3 kips is less than what I would need, so this is a solution for our problem.